Hi everyone, today we are building a memory helper app. So it's going to be a grid, there's going to be some digits on the grid and they'll appear in random places. The digits go from 1 to 9 inclusive, and the player's task is to remember the sequence and also the locations of the digits. And then they'll be tested based on time or something. We'll come up with something interesting. This actually was part of a research study that I did a while ago. It was something to do with memory testing. I don't actually know what that was. I just thought it could be turned into a game, because it essentially is a game. Oh yeah, I've forgotten that I'm not using FXGL. This is plain JavaFX, by the way, so we'll have to do a bit more work to get things set up. What's the root node? I suppose vertical box, because I want to have a button that allows the user to reset, kind of thing. Let's set this to 720. That's how big the grid is going to be, so plus some margin for buttons like controls. 100 should do it. And then just return this. So we need a tile, right? So we need some kind of representation of a tile. Let's go for tile view, which extends stack pane. No, it doesn't extend an error, it extends pane. Tile view, it takes something. What does it take? We could pass in integers, I guess, because they're going to be digits, or they could be just strings. Content for that tile. And then we're going to add a border. Just use a rectangle for that. You could do this with CSS, but I can never remember the actual CSS for it. So rectangle, right, so 1280, I need to figure out the size of each tile. Something that this thing is divisible by and this thing is divisible by. 40? We'll go for 80, 80 is big enough. Fill is going to be null, because the only thing I want is the border, so set stroke to color black. Increase the size of the stroke to maybe 4, and make sure it draws inside. So stroke style, stroke type inside, because we don't want it to go beyond 80 pixels. Going to add it, get children, border. Because we're extending from stack pane, it's going to center it, which is nice. We're going to build our text now. I can do it here, new text. Nope, not the border, the content. Make sure you're using JavaFX imports, because some of the AWT classes have the same name. Set font to something big, so it's really clear. If the border is 80 by 80, then something like 64 should be nice, I think. And then we're just going to add all of the things in here. So text, set font. By default, I think the color is black, so it should be fine. Now let's populate this. So we start at 1 and we go up to 9. The actual study went even beyond that. Like, once you've completed this test, they introduced things like words, which is much harder because with digits you have the predefined order kind of imprinted in your brain. You know it's 1, 2, 3, and so on. With words, they're unrelated, so you actually needed to memorize new things reasonably quickly. And then they went kind of beyond that. They added symbols, characters, images, and remembering sequence for that is much harder actually. Tile. I'll just do integer pass. Nope, to string I. So that tile, I'll use string here to be kind of a bit more general in case you want to step it up a bit. Root get children add tile. We need to make sure to move the tile to a random thing, right? Let's use random. Right, this is a vertical box. This won't work. So we need, because it's going to just position everything vertically, we need something in there like pane, tile pane, there we go. And that is where we're going to put these things. And then this could just be inside the root. Root get children add tile pane. Yeah, I need to update my IntelliJ. Set translate x random next int. This is the end is inclusive, right? Yep. So it's between 0 and this value, whatever that is. 16, I think. It's been a while since I had to do maths in my head. And then it's 720 divided by 80. Yeah, because that's 80 by 80. So that's going to give us the number of tiles. But because it's random and exclusive, it's going to subtract 1 from it, which gives us a valid value, which we're going to then multiply by 80 to convert from the grid in this grid locations to pixel locations. And that should be it. That's everything we need in order to place them randomly. Shall we give this a go? And then we need to add the ability to hide and show a tile. We need a button and we need a timer. That kind of works. Yeah, I'm happy with that. And then the user will need to then do 1, 2, 3, 4, 5, 6, 7, 8, 9, but while the tiles are invisible. Actually, just the digits are invisible. You can see the tiles. And then you can make this even more difficult by adding words, because words don't really have a relationship between each other. So the order is not predefined. So they have to actually learn the order, memorize it, and then reproduce it. So let's add a button. New button start. This is the thing that's going to kick it off. So it's going to be our grid tile pane and then button underneath. button starts something. Set on action. Start game, shall we call it, because there's already a method called start. Start game. We also want a click, so tile set mouse on mouse clicked. So we need to figure out that, and each tile needs to have the ability to hide, because they're going to be shown by default. We don't need to show them because they're by default on, visible. When we hide them, we're hiding just the text. So it's this bit, this thing that needs to be text, so that I have a reference to it, and then set visible false. Because the background is transparent, I think we need to turn on something like pick on bounds. Yeah. Because otherwise the mouse event is going to go through the tile and will never actually call this thing. Start game is going to do this. Actually, we need to extract this somewhere, because if this thing is on by default then the user already sees it. We can't have that. Populate grid. Yep, that's just nice because we're able to extract it. Need to do something about that. Well, we can just add a dummy pane there. And then when we start the game, we're just going to replace the very first node of the root with this. And if we do that every time, then that works. So we need to have access to the root. And then we do populate grid, which returns a pane, maybe a parent. And then root get children set element 0 to this thing. So this will allow us to keep repeating the game, which is important. So if I start, it does this. For whatever reason, it goes interesting. So if I click start again, I can redo this. It probably thinks that the size of the pane is small. So can we resize it? Something like this. So that JavaFX can compute it. Yeah, that's better. So the start button is below the thing. You might want to draw some kind of a line here, like a separator, so that you can see the sort of the things. Right. This is looking. I haven't thought about this case where the random value gives you the same value, the same tile position. We can fix that. So it's random x, which is this, random y, and we can't have the same pair, which means we need to store them somewhere, I guess. List of points used points, and then we're just going to add to that thing so that we can then check if we've used a point before. So we get the random, and while this point used points contains p, we need to keep doing this. Yep, that's probably the straightforward approach. By the time we exited from this loop, we know it's a unique point that doesn't exist in used points, so we can add it and then use it. Sound good? There's quite a bit of repetition here. I think you can refactor this if you're using do while maybe, but I'll leave it at that, so I'm not too worried about this. For now, I'm worried about the click I need to handle. So tile, mouse click, I need to hide the tile. No, it's the other way around. The tile needs to be hidden after a certain period of time, right? So we need duration. We need static final double duration, duration in seconds. This is how many seconds the player is allowed to look at the numbers before they disappear. 7.5 or something like 15.5. 15 sounds a bit much. I think the number that was used in the study was 3.5, so it was actually pretty fast. I'm going to give myself a bit more time, maybe 6 seconds. So when we start the game, we populate the grid. We then kick off the timer, which we don't currently have. Just going to use one of the services, one of the background threads, timer thread. New single thread, scheduled, single thread scheduled executor. Yeah, that's the thing I'm looking for. Submit. Nope. I think I will not use the correct interface. Scheduled. Yeah, we'll need to use this particular interface, so I can call schedule. Just once, right? Yeah, it's one per start, per game start. So the function to execute the delay, which is 0. No, not 0, it's the duration, the thing that we're going to pass in. And then unit, which is going to be seconds. So we have to use a long value, which is fine. Something to be called, then duration, seconds, and then time unit in seconds. So we're saying this is how many seconds, but we actually need to tell the thread that what kind of unit of measurement we're using. And then the code to run is we go through all of them and we hide them. We go through all the tiles and hide them. The tiles are accessible, hopefully, from here. Yep, that's perfect. I have the reference right here. Tile pane, going to use it here and get children for each. Nope, we're going to have to map it because it thinks it's a node, but it's actually something else. Well, it is a node, it's just a subclass of it. So we're going to map it. The only thing tile pane contains are the tile views. So we're going to map this node to tile view so we can then access its specific method that we need, which is hide. For each tile view hide. A bit of stream API there. We talked about it a couple of times. And then the last thing I need to add is the click handler. And after 6 seconds, the things disappear as if by magic. And you need to remember where the digits were. Right, so this works. Let's start it again. If I can remember 5 digits, I think I'll be fine. The rest, I'm not too worried about the rest. You'll notice that your JVM didn't exit, so you'll have to manually shut it down, or you can gracefully exit by actually shutting down the thread, which we can do somewhere here. So start, there's a stop method that you can override. This is the method that will be called when the application, the JavaFX application, is shutting down. So we can clean up our stuff like this one. Shut down now. Because it's a background thread, and it's a thread that will keep the JVM from exiting, which means you have to shut it down so you can cleanly exit and not manually. Start is going to do its own thing. I close the application and JVM shuts down. So that's fine. And the final thing is click. So what do we need to do on click? We need to check if the tile that we just clicked is in the correct order. The tiles are present in this tile pane, which I think we can use. I'll just rename this to just pane, since it's a local variable. I don't want to shadow it. Shadowing is when you have an instance level variable, which is accessible from the method you're writing in, and you have a local variable in the method that has the same name. It's hard to read. Not that we're focusing on architectural good practices in this video, because it's a one-off video, so one-off program, so architecture is out of the window. Tile, on click, what do? We have the reference to the tile pane, which now I'm thinking we probably don't need, because we need to store the order somewhere in a different container. Well, since we already have it there, that's fine. List of tile views, tile sequence is what I'm going to call this, and we're going to populate it in exactly the same way as we add to our pane, because we go from 1 to 9, right? This loop goes from 1 to 9, so the order is preserved in this list. What I can do now is always remove the top element, which is element 0, when I click. So if tile sequence is empty, then the game is basically over, and we simply return from this. I'm still doing defensive programming, even though we don't really need this, because, you know, even if it crashes, it's fine. So if tile sequence is empty, otherwise we're going to get the correct tile. We know it's correct because it's, well, it's an order. So tile sequence, remove index 0. It's going to shift all the elements up top by 1 because we've removed the top element. We know the top element is the correct one because we have to go from 1 to 9. And then all we need to do is just check the references because they are the same reference, as in they're the same object. So this and this, if they're equal, then we're good. Well, then what do we do? Do we show it? Yeah, I guess we'll show it to make it a little bit more interesting. Set visible true. So we show that specific tile that the user could collect so that the user knows it's a valid tile. Else the game is over. Here we can say the game is already over because, yeah, tile sequence is empty. And we can empty the tile sequence, just clear it. Is there anything else we need to do? So this is going to appear. Technically, you should also check whether the user is in the kind of waiting mode, because currently if you click on that, it will still kind of work while the user waits. But that's just too much work for this simple example, which I think we've completed, more or less. Let's give this a go. One, two, three, four, five, six. That's what I could remember. I wasn't even looking at the other ones. I knew I could remember maybe 5 or 6. And then the rest is just guessing. It's 0.7? Nope. So we failed. Can we restart? Six. Nope, failed again. I'll give it one more try just to see how it goes. It was the other way around, 7, 8, 9, I think. Anyway, this is a fun little game, and hopefully this can help you with short-term memory. That's kind of the pun in the name of the game, NuMemory, which kind of stands for numeric memory, but also new memory. On that note, we've done a bit of background thread scheduling, which allows us to run something after some period of time. You can also, there are a bunch of methods you can call. They're quite interesting if you want to do something with background threads. You can schedule at fixed rate with fixed delay and so on. You've got this thing, which we don't normally do because we don't have background threads, but it's quite a nice thing to know because in a real world application, you want to have as many threads as possible so that you can, you know, quickly do a lot of things. We're using background thread here for slightly different purposes rather than offloading the work to a background thread. We're using it because there's a function that's really nice. I didn't feel like counting values manually so we can get duration seconds in the animation timer. We've looked at using random values to position the tiles, and also did a little bit of styling the tile. Okay, on that note, thanks for watching, and I'll see everyone in the next video.